Edx M3 June 2011, question 1. A question on variable acceleration where the acceleration is a function of displacement x. You might like to pause the video and just read the question there and then resume playing when you're ready. So I've just put the question in again and drawn a little diagram here to alert us to the fact that because f is acting towards O, in other words, in the direction of x, in the direction so as to decrease x, f, we have to call f negative. Okay, so it's f equals minus. I should have put a minus there, I suppose, really. But I was showing it with the arrow as we're acting towards O. So writing down f equals minus 0.375 x squared. 0.375 it should be. Right. The mass is a half, so divide by the mass to get the acceleration, and we get acceleration is minus 0.75 x squared. Now, in questions like this where the acceleration is in terms of x, we don't want to express acceleration in terms of t. We don't want to write a as dv by dt. We need to write it as v dv by dx equals minus 3/4 x squared. We can separate the variables there and integrate it like this. And carrying on the left of the page, which I know is sort of the wrong way around, but there's some room there, we'll get v squared over 2 equals minus x cubed over 4 plus a constant. Now let's look back at the initial conditions. We were told that when t is 0, OP is 8, so x is 8 and v is 2. So x is 8 and v is 2. Just be careful here. V is minus 2, in fact. Alright, because p is moving towards O with speed 2, so v is minus 2. Putting that into the equation then, we get c equals 130. You might like to pause the video and check that yourself. Yep. So v squared equals, doubling everything, v squared equals 260 minus x cubed over 2 when you double everything, which is the expression that they want. Okay, just to point out, although I made a point of saying that v is minus 2, it doesn't really matter in this because in the equation we've got v squared anyway, so it wouldn't affect c. So that gives us v squared. For the second part, we've got to find the distance from O at the instant when v is 5. Well, we've got the relevant equation. This is only 2 marks. We know v is 5 now, and we want to find x. So we have 25 equals 260 minus x cubed over 2. That gives us x cubed equals 470. And then x comes to 7.77 meters. And that's 2 marks for the last part. For the allocation of marks throughout this question, in the first part you had an M1 for the correct expression for f with a minus sign in there. Then you had an M1A1 for writing a as v dv by dx, separating the variables and setting up the integral. And that's 3 marks. There's 4 marks for this. And then you had an A1 for finding the correct value of c, and hence the expression for v squared. So that was the 4 marks for part 1. And for part B, it was just one method, one accuracy mark. So the method mark was for putting v in this equation, and the accuracy mark was for getting the correct x. Okay, that's question 1 done.